So this is actually going to go pretty quickly. I only assigned 2 questions for section 10.2, and here they are. So the first question here says we have a Gallup poll that was asking a question to the nation. So the years that this question was asked was 2003 to 2006, and the question was, what do you think is the most important problem facing the country today? So you can see that the responses are given. They had 3 very specific categories: war, economy, healthcare, and then a very broad other category. Now, in Part A, it says they want us to assume that 1,000 people were surveyed each year. Thankfully, 1,000 is a pretty simple number to convert. All we have to do is take those percentages and basically put a 0 where the percentage sign is. So the first row should say 190, 200, 90, 520, etc. And that'll convert those numbers to their actual frequencies. Now, once we convert them to our frequencies, you'll notice in Part A it says to create a segmented bar chart. Obviously, I'm not going to ask you to do that on the quiz because I want you to be able to type in as much of your answer as possible. I know some of you have been sending me screenshots, which is fine, but at the same time, I don't want to force anybody to do that. So I'm just going to show you what that segmented bar chart should look like. So towards the middle of the screen here, on the left, you will see a segmented bar chart for the years, and you can see that they've basically just shaded in the amount corresponding to the frequencies. So that's what those would look like. You can tell that there's definitely some discrepancy. It looks like 2003 and 2004 were about the same. 2005 is where we saw a little bit of a change, and then it almost appears like 2006 was starting to go back towards the opinions that people had in the first 2 years. Let's go back to our question. So Part B says, what are the populations in this case? This one's pretty straightforward. Since they asked a question of the nation, we're going to assume that this just represents the opinions of the American, population. Now, they didn't specifically come out and tell us if they focused on a age group of like 18 and older, but it wouldn't surprise me if that is the case. It is Gallup, so it would have been nice for them to tell us that these were random samples, but that is a major polling organization, so I think that's a pretty safe assumption. So that means going into Part C, when we perform a chi-squared test of homogeneity, we know that we're going to be basically determining not where the issue is, but whether or not one of these years had a different distribution than the others. So we're going to look at the 4 years and see if the distribution of responses remained consistent across all 4 years. All right, so let us go ahead and do this. So we already said we'll kind of assume that this was a random sample since it was done by Gallup. Now, other than that, some of the other conditions that you need to check are you need to check that everything falls into exactly one category. Now, of course, it says most important problem, and the words most important seem to imply that you can only pick one of these results. So that being said, I think falling into one category is fine. The next thing that we want to make sure is that the expected frequencies are all at least 5. Now that, of course, becomes a pretty interesting one because I told you that I learned in my second year of teaching this that we don't actually have to go to the trouble of finding the expected frequencies. So let's go to the calculator and let's see what this looks like. So on my calculator, you're going to see that I've actually already taken the time to type in the numbers. To get to the matrices, you're going to hit second, then you're going to press the inverse key, which will take you into the matrix menu. I'm going to scroll all the way over to edit, even though we're not going to be editing anything, because normally whenever you would be doing this by yourself, you would need to change the dimensions. There were 4 years for the rows, so 4 rows. There were 4 possible answers, so those were in the columns, so I chose a 4x4. You can see I've changed the percentages to actual frequencies. Do not type them in as percentages, or basically every question, it will be assuming that you are using a sample size of 100. And the more people you have, the more likely that is to affect your p-value. So you definitely want to make sure sample size is taken into consideration. So now I'm looking at the results. These are the observed results. But in order to get the expected results, we were supposed to use that formula from the section. Row total times column total divided by grand total. It's not a horrible process, but if I just press stat, I go over to tests, I scroll way down towards the bottom of the list, and I find the chi-square test. That's option C on my calculator. It'll say, where are your observed values, which you can see I put them in A, and I always thought asking where we put the expected values, but if you don't have the expected values, it'll do them for you. So we can just put B here to represent that we want them to put the expected values in B. And I'll press calculate, and it's going to run the test. Now ignore the answer for just a moment. We're going to hit second, and we're going to go back into the matrix menu by pressing inverse. You will now see that there is something in number 2. And if I go over to edit and pick matrix B, you can see that it has filled in the expected values for me. So for the first column, I should say, they were all 205. For the second column, basically it's telling me that this is what I should have expected the results to be if they were approximately the same for all 4 years. So there you go. So I didn't have to do any work there, which is pretty nice. It's filled in the results, and then I can see that clearly those were all much, much larger than 5, so no problem there. Okay? All right, now let's go over here to the answer key. And you can see that if we come down here to where we would have checked the conditions, it says the conditions are met. A random sample of 1,000 was taken from the U.S. population each year. That's the important part, is it had to be populations, plural, taken over a certain variable. In this case, it was year. Each response fell into one category. All of them were at least 5, so we can proceed. So what would have our null hypothesis been? Right, let's look at the way the book wrote it. It says, if every year from 2003 to 2006 you had asked all adults in the United States this question, the distribution of responses would be the same for each year. I think that's probably a little more wordy than it needs to be. I would just say the distribution of responses from 2003 to 2006 for the population of U.S. citizens that answered the question remains the same. So the distribution of the responses from 2003 to 2006 remains the same. And then my alternative hypothesis, remember this is important, in at least one of the years, the distribution of responses was different than the others. So it doesn't mean I'm specifically trying to see that in 2005 the responses were different. This test only tells me that in at least one of the years the responses were different. So again, this is why this is more of a step 1 of multiple steps in doing an analysis, but nonetheless, that is what we are doing. Okay? So let's go back to the calculator. Go back to the home screen. Hopefully it won't delete it on me. And shoot, it deleted it. So the downside to this browser version of the calculator is sometimes it doesn't save everything very well. And now it's really being mean to me because I didn't even press a button and it deleted it. Alright, so earlier you would have saw this on the screen. We got a test statistic of 113.45. Thinking to a z-score, that would be so far to the right it's crazy. On this chi-squared test statistic, it is still very, very far to one side, giving me a p-value of 2.9 times 10 to the negative 20th. It's not technically 0, but it's basically 0. So we got a probability so small that realistically, this was not an accident. No, we did not find the most rare example of all. We have clear statistical evidence to show that in at least one of those 4 years, the distribution of responses was not the same as in the other years. So basically, there was not a uniform distribution of responses across all 4 years. Okay? So that is what the question was determining. Were the responses basically the same for all 4 years, or did people's opinions change? And we have clear evidence to show that in at least one of those 4 years, opinions changed. Not a surprising result. Honestly, pretty much what you would expect. So you can see that test statistic and p-value. We can double check those with what the answer key says. You can see the test statistic was, in fact, 113.4, giving me a p-value, the book even says, of approximately 0. Okay? So I'll leave this part on the screen for just a second or two in case any of you want to read what the book results were for any of the other parts or the detail to some of their stuff. You can pause the video and take a look. All right? Now, the other question I had you do was number 21. It says, suppose an experiment is designed to determine the effects of a bandage on the amount of pain a child perceives in a skinned knee. So it's kind of a weird little experiment, but basically a bunch of kids came in after they got hurt, and the experiment was, let's give them different types of bandages to see if the kids, in fact, feel like the bandage that they got helped their pain. So it was basically a quick little like, hey, is this all in the kid's head, or did they actually get hurt kind of deal. We know that there's a lot of variation from person to person, and there's probably a ton of other variables that would go into this, but we're trying to assume that the only major variable here is the color of the bandage that the students are receiving when they came in to have their injury looked at. So, interestingly enough, if you read through the question, some of these numbers might be kind of hard for you to decipher. You'll want to really take your time when you're reading them. Because I've already worked through the first one, I would like us to focus on the results here. So let's say that you took the time to read through the question. You would really want to make sure that you got the 9 numbers that are not quite as bold as the other numbers in this chart. So you do not have to organize your chart this way. You can literally have those 9 numbers anywhere. So if you put the no bandage in the middle column, you're fine. If you put the no bandage in the 3rd row, you're fine. You just have to make sure that bandages are either all across as your columns, or that bandages are all going vertically as your rows. So it doesn't matter which one is the rows and which one is the columns. It doesn't matter which row is which or which column is which. So you just need these 9 numbers organized in some way similar to this. All right? So you might have your numbers in a very, very, very different position than they have their numbers, but realistically, as long as you had those 9 numbers positioned in the same rows/columns, you're fine. So since in row 1 they have a 0, a 9, and a 15, one of your rows or one of your columns should have a 0, 9, and 15 in it. And it doesn't even have to be in that order. So it just should have those 3 numbers in it. So kind of hard for me to tell you exactly what your matrix should look like, but it should at least have those 9 numbers in them, hopefully organized in a somewhat similar fashion. All right, so let's just jump into it. If I'm going to perform a chi-squared test on this, was this a random sample of kids? Not really, but it's an experiment, so it doesn't have to be a random sample. They just had to randomly assign the bandages to the kids, which they did. Check. Now, the big issue I have here is I think we can assume that they pretty much fall into only one category, but the expected values, we have a 0 in there, we have 2 2s, we also have a 3. Are the expected values actually all going to be at least 5? So if you plug those 9 numbers into matrix A, you would need a 3 by 3 matrix. Remember, you do not type the totals in to your matrix. So if you have the 0, the 9, the 15, the 5, the 9, the 2, the 15, the 2, and the 3 in matrix A, then all you have to do is go to your chi-squared test, make sure the observed values are matrix A, and then just tell it that the expected values are in matrix B. Do not change anything. You do not have to delete the previous one. It'll all be fine. If you run your test, it should change matrix B into a 3x3 matrix, and you can see that the results are either going to give you rows that are all equal or columns that are all equal, depending on how you organized your data. But you'll have 3/8, 3 6 2/3, and 3 5 1/3 results. And even though it barely qualifies, 5 1/3 means that all the expected values are in fact at least 5. So it doesn't meet it by a lot, but it does meet the conditions. Okay? Now there's a segmented bar graph if you're interested in seeing what that would look like. I think at glance it's pretty obvious that it does not appear that these results are very consistent, but I suppose you never know until you actually run the test. Now going back to the original set of data, notice that the thing that they had 20 of each of was the bandage. So I think for my null hypothesis, I'm going to say that the distribution of pain perceived by the children is approximately the same for each type of bandage. So yeah, so it's going to be one of those things where I'm going to say that the pain distribution is equal for each type of bandage. Now I've had students who have said, well, could we say that the bandage distribution is the same for each level of pain? I think so. I don't think it's as good of an interpretation, but honestly, I think that would probably be okay to say it that way. Keep in mind that your samples that were chosen were based on getting 20 of each type of bandage out there, though. So I do think that you're focusing on the distribution of pain perceived based on each bandage. So that's going to be my null hypothesis. Let's see the way the book wrote it. Suppose all 60 children could have been given the no bandage treatment, all could have been given the skin color treatment, and all could have been given the brightly colored treatment. The proportion of answers that would have fallen into each of the three categories would have been the same for all three types of bandage treatments. Basically, just a much, much wordier version of what I said. I don't believe the first half of their null hypothesis needs to be stated. If you want to put that in there, you can. But I would just simply say the proportion of pain levels is the same for each type of bandage. Something like that. And then the alternative, you definitely want to make sure you say at least one. For at least one of the bandages, the proportion of pain level was not the same as the other two. Or you could just say that the distribution of pain level was not the same for every bandage. So as long as you state it something like that. Now, assuming you ran this on your calculator, we can see the test statistic is here, but let's just look at this here. So we should have gotten a test statistic of about 34.58, giving us a p-value of 5.7 times 10 to the negative 7. So 5.7 times 10 to the negative 7. So honestly, with the results in the bar chart that looked as different as they did, I would have expected this to maybe even be a smaller p-value. Nonetheless, that's still a very, very small p-value, almost 0, which means that the result is significant. And so once again, you reject the null hypothesis, and you have evidence to support that for at least one of the bandage types, the distribution of pain was not the same as the others. So, at least psychologically speaking, for those children, the bandage color, or lack of color, you should say, one of those things affected the way they perceived the pain of their injury. So anyway, guys, obviously there's other variables such as how bad their injury was to begin with and things like that, but they're really just having you kind of focus on some scenarios to run a chi-squared test of homogeneity. So hopefully this made sense to you. Obviously typing into the calculator is much different than last section. So far you guys have been doing real well. Pretty proud of the answers I've been seeing so far. A couple of you have been struggling a little more than the rest. Remember, I'm available for email questions all the time. I typically get back to most people who email me within an hour. And I also have those 2 guaranteed hours for office hours. I took the time to mention to my geometry students that if they needed to get in contact with me very quickly, if you guys do have an iPhone or iPad and you use iMessage, you can send a text message to my email. I have my email attached to iMessage. So if you guys do that, I will get the message directly. So feel free to use that as well, so that if you do need to get in contact with me very quickly, you could do that. So anyway, guys, that's the end of the 10.2 questions. The 10.3 questions will come out this weekend. I'll talk to you guys in that video.